So here's a question about stopping distances, and stopping distance is made of both thinking distance and braking distance. So here's a good one for practicing your definitions and being absolutely sure about the definitions of the terms that we're using. Hi there, I'm running through this paper, which is the second higher paper. It's paper 4, OCR Gateway. Okay, and this one is all about thinking distances and braking distances being added to make stopping distances. And actually it's an experiment that some students have been doing using stopping distances with their bicycle. There's really core knowledge that you need to get your head around in there. Okay, so students in class investigate stopping distances using their bicycles. Fun day, fun lesson to do that. They compare the stopping distances of one student riding a bicycle at different speeds. Look at the results they collected. Describe how halving the speed affects the thinking distance. Well, you can do this using this data, can't you? Well, you can see that half the speed, half the thinking distance. So you need, though, to use that. Saying decreases is not good enough, okay? So halving the speed halves the thinking distance. If they give you numerical information like half, use that. Describe how tripling the speed affects the braking distance. Well, from 2 to 4, the braking distance isn't doubled, and from 2 to 6, the braking distance is not tripled. So how does it actually affect it? Tripling the speed, you need to bring a bit of knowledge to this, actually increases it by a factor of 9. Or you can look at the data, 10.8 divided by 1.2 gives you 9. So tripling the speed increases braking distance by a factor of 9. Okay, so it's 9 times greater. I've done those as a little pair, but there's a mark obviously for this one. You don't need to explain why it is, but halving the speed changes the thinking distance, because the thinking distance depends on the reaction time. So if you halve the speed, you go half as far in that same reaction time. So it's about the difference between thinking distance and thinking time. Describe how tripling the speed affects the braking distance. Well, in braking, you are dissipating energy. So once the brakes have been clamped after the thinking distance, you're dissipating energy, and kinetic energy is a half mv squared. So tripling the speed increases the kinetic energy by 9 times because of the v squared. So we say the energy is proportional to the velocity squared. Very important thing, and really you need to just remember that. Double it, you quadruple the energy. You triple it, you got a factor of 9, so 3 squared times the energy. So the student travels at a new speed, he has to brake suddenly. The reaction time for the student is 0.8 seconds and the thinking distance is 7.2. Use the formula distance is speed times time. So here they've given you the formula, so you do need to memorize all these formulas, and I've got a book that tells you how to memorize the formula, but they haven't given it to you the right way around. So one of the marks is for doing the rearranging correctly. So here speed equals distance divided by time, which is 7.2 over 0.8, 9 meters per second. Okay, the next one, the student now travels at 8 meters per second. Calculate the new stopping distance at this new speed, 3 marks. So essentially you need to fill in this last column. Well, we've said that doubling thinking distance doubles that, so we can straight away figure that one out as 6.4. But doubling the speed quadruples the braking distance. So I need to, from 4 to 8, I've doubled the speed. So from 4.8 to this, I need to times that by 4 because of the factor v squared. So 4.8 times 4 gives me 19.2. Okay, so to get the stopping distance, I have to add those two together, giving me 25.6 meters. Now here you get a mark for the thinking distance, 6.4, regardless if you didn't do anything else. If you got thinking distance 6.4, you get a mark. You get a mark for the braking distance being 19.2 meters, and you get a mark for adding together because it's asked you to calculate the stopping distance, not just either one of them. 5 students in the class measured their reaction time. Look at the results. Here they are. the average reaction time is 8.1. Calculate the reaction time of student E. So this is really just a maths question. You need to first of all figure out what the total would be. Okay, there were 5 results, so 0.81 times 5 gives us 4.05. So that is the sum of all 5 of these, including the one that we don't know. So I need to do 4.05, take away the sum of these. .85 is the unknown reaction time. It's difficult to measure the thinking distance for the student on the bicycle. Now, a lot of people have been talking, they don't know what he's thinking. Suggest why. Okay, it's hard to tell exactly when they have reacted to the hazard or to the obstacle. It's hard to tell exactly when they begin to press the brakes. It's hard to tell exactly when they notice the obstacle in front of them. Okay, so that is what we needed to get in here as our answer. Okay, so or exactly when or exactly where is also acceptable if you're trying to measure the distance. So either of those two begins to react or begins to press the brakes. Now, if you've just said you don't know what the person's thinking, then you haven't gone as far as saying it's difficult to tell exactly when or where something begins to happen, reaction or pressing the brakes. You need to be that detailed. Name 2 different factors, so just name 2 different factors that may increase reaction time. So have we been given any factors already? I don't think we have, so they've just got to be different from each other. Okay, reaction time, well, if you are drunk or on drugs, okay, so you are inebriated, then that could be one of them. So let's just put effects of drugs or alcohol. Okay, another factor might be a lack of concentration. Okay, so distractions or a lack of concentration. Other ones you could say in here, these are both work and mark. If you are tired is the other one that you can actually have there. It's important that they are different from each other, so some answers I got were drugs for one, alcohol from the other, or distractions and not concentrating, but they're really the same thing. So they've got to be different from one another. And again, 2 different factors that may increase braking distance. Okay, just from your memory, braking distance could be greater speed, and that's the one we've discussed on the previous page. Could just be worn tyres. Not just tyres, not just speed. Okay, and then the other one might be the conditions of the road, but again, not just conditions of the road, wet road, icy road, something like that. Okay, so a mark for 2 of those. I hope that was useful for you. This is Gorilla Physics. I'm Kit Vets Masters. I'm all about you understanding physics more so that you're going to enjoy yourself more, and get more confident, and you're going to do better in your exams.